We'll talk about the recessive epistasis. Now, in the case of the recessive epistasis, what will happen that this is the epistasis when if only and only both the enzymes, or you can say both the genes are present, that time only final, or you can say the dominant color or dominant trait can be observed. I repeat, in the case of the recessive epistasis, now we all have learned in the case of the dominant epistasis, the epistatic, uh, if the epistatic gene is present even in a single dose, so that is sufficient, and it was not related to the hypostat. If hypostat is present or absent, the dominant gene alone was sufficient to produce the dominant color, right? But in the case of the recessive epistasis, the both the genes are required, epistatic as well as the hypostatic, to form the dominant type of trait. I have taken the same example of the color only to make the things easier for you. Say example, again I have taken the white substance. If the enzyme A, which is epistatic, or you can say, why I am telling it epistatic, because if it is absent, no color is going to form, because this is the thing, or you can say this is the gene which is going to utilize the substrate first, and whatever product is going to be formed by the epistat, that product will be the substrate for the hypostat. Understood? So here what is going to be happen, if the white substance is present, if that is converted into the red substance by the epistatic gene, or you can say the intermediate dominant, and if that intermediate dominant product will be utilized by the second gene, which is hypostatic, the dominant product can be formed. So what we understand by this, we understand that until and unless both the genes are present, the final product cannot be formed. Is it or not? Now for this I have made the table already, because we have a very good practice to make table till now. So same table will be there because I have taken the same labeling of the gene. But now here again making table is not the task. Now tell me which will be purple. Capital A, capital B. This will be purple. Yes, here capital A is also present, capital B is also present. So this will be purple. This will also be the purple one. This will also be purple. This will also be purple. This will also be the purple one. This will be. Now point to remember, if enzyme A is present, or you can say only epistat is present, it is going to be the red one. Understand? So only A is present, so it can form red color. This here capital A is also there, capital B is also there, so this can form the purple color. Here only capital A is present, so red color will be observed. Here capital A, capital B both are there, capital A, capital B both are there. Now capital A is only absent, which is the epistatic. So here it will not be able to form any color. Why? Because for the formation of capital A, until and unless A will not form red color, B cannot work on it. So it will remain white. Understood? Here again this is the case of white only. This will form the purple color. Now here only A is present, so definitely it is going to give red color. This will give white, sorry, This will also be the white one. So I can see 9 purple are there, right? Count fast. 9 purple, or you can say the dominant one are 9. Then red 3 and 4 white. Understood? Now here the count of the recessive is more, so for that particular reason this type of interaction is called as the recessive epistasis. In the next lecture we all will be learning about the double dominant and the double recessive epistasis. For this note we'll stop, and I just like to remind you about the assignment which you have to solve and just tell me what results you are getting. This is the assignment. Take the screenshot of the assignment. You have to solve the dominant epistasis assignment and just revert me what answer you all are getting. So for this note we'll stop now.